So we've finished our unit on graphing quadratics and solving quadratics. So now we're moving away from that to logarithms. So unit 8 is on exponential and logarithmic functions. Our first lesson should be somewhat of a review. It's on rational exponents. You're going to need your note sheet, obviously, to start out, but also if you have your square root chart, it might come in handy as well. So today we're going to apply the laws of exponents with rational numbers. Okay, rational numbers can mean numbers that are in the form of a fraction or a decimal. So just be prepared for that. It says the numerator of a fraction m, in this case, m is the numerator, represents the power. M is the power. The denominator of the fraction, which in this case is n, represents the root, such as a square root, cube root, fourth root, etc. The exponent in the denominator must always be positive. These two work the same. Base a with the exponent of m over n. This is like this, a to the m over n. It looks kind of big, but that's what it means. Your exponent is a fraction, equals the nth root of a to the m power. So these work interchangeably. It means that, remember, the numerator m represents the power with the base. The denominator n represents the root. Is it a square root, cube root, fourth root? What is it? Okay, so let's look at these examples. These are already done for you. X to the 1/2 power means this is x to the first power. Usually we don't write the 1 because it's understood there. And then it's all to the second. The root is 2, a square root. And again, we don't usually write the 2 for the square root. We just assume if nothing's there, it means square root. So when you see the square root of x, that is equivalent to x to the 1/2 power. They mean the same thing. One's written as an exponent, the other's written as a root or a radical. 9 to the 1/2 power is equivalent to the square root of 9. And what is the square root of 9? It's 3. X to the 2/3 power means the cube root of x squared. Remember, the numerator is the power, the denominator is the root, the cube root of x squared. So we're going to quickly talk about the laws of exponents because we're going to be using them a lot today. So the law of exponent, the first one says if you have the same base, they're both a, and you're multiplying, then you add your exponents. Okay? Multiplying, same base, add exponents. I'll write that there. Multiplying, same base, add exponents. A to the m over a to the n. This time we have the same base. It's a. We're dividing. We subtract our exponents. When we did these, we used to say, if we have the same base, are there more exponents in the numerator or the denominator? How many more? And that's where you would put it, okay? But the rule means if you're dividing, same base, subtract exponents. Then we have the product of a power. This is a product raised to a power. It means you're sharing that power to both. It becomes a to the m times b to the m. Share exponents. Then we have a quotient of a power, and this means we're also sharing the exponent. And then finally, we have a power to a power, and that means you're going to multiply exponents. So this is power to power, multiply exponents. So there's going to be a lot of variety of the type of practice problems we're doing. So hopefully it'll help you when you go to the homework to do it. But just know that a lot of these aren't going to look the same. They're going to look very different. So we're going to start and we're going to simplify. So let's see what it's asking us when we simplify these. So remember, if I have 16 to the 3/4 power, that's an exponent form. That's not simplified, but I can now turn it to radical form. The base goes inside the radical. Remember, the 3 is the power, and it's the 4th root, okay? So we know, and I kind of sometimes like to do it this way and put the 3 on the outside. We know that 16 is a perfect 4th root. If you've forgotten, look at your chart. If you have your graphing calculator, punch it in. Do the 4th root of 16. It is 2. Okay, 4th root of 16 is done now. 2 cubed means 2 times 2 times 2, and that is 8. 16 to the 3/4 power meant nothing. But when we were able to convert it into radical form, we got an answer of 8. That was number 1. Let's go to number 2. 25 to the negative 3/2 power. Again, we're going to take it out of exponent form. We're going to put it into radical form. When we do that, this becomes 25 under the radical. It's the square root. So if you want to, put the 2 there. Otherwise, it's already understood that it's there. And then it's to the negative 3 power. What is the square root of 25? It's a perfect square. It's 5. 5 to the negative 3rd power. Well, we're not simplified because whenever you have a negative exponent, it is not in simplest form. What do we do to that? We move it to the bottom. So this becomes 1 over 5 cubed. And 5 cubed means 1 over 5 times 5 times 5. So that means 1 over 125. That's 1/125th. All right, number 3. 9 to the 2 5/10. Now it's a decimal. 2 5/10 power. Okay, so 2 5/10 is equivalent to 9 to the 5/2 power. Why? Because 2 5/10 becomes 2 1/2. And when I turn that into an improper, that's 2 times 2 is 4 plus 1 is 5. Okay, now I'm going to take it out of exponential form and put it in radical form. 9 is the base. Again, it's the square root, and it's to the 5th power. The square root of 9 is a perfect square. It's 3. 3 to the 5th power means 3 times 3 times 3 times 3 times 3, which is 243. Okay, let's do another one. Number 4. Negative 32 to the negative 3/5 power. Again, it's an exponential form. We're going to turn it into radical form. 32, negative 32. Okay, I don't want to worry about those negatives inside the radical. I'm going to break this up to negative 1 times 32 to the negative 3/5 power. So that negative is going to stay on, it can stay on the outside as we do this. So as we do this, we now know that this is a negative exponent. Negative exponents go to the bottom. This stays on the top. So this is going to be negative 1 over 32 now to the positive 3/5. It changes that negative. It makes it positive. But this didn't move. This stays. Okay, so we have negative 1 over 32's inside. It's the 5th root of 32 to the 3rd power. And the 5th root of 32 is a perfect 5th root. It is 2. And 2 to the 3rd power means 2 times 2 times 2, which is 8. So this is negative 1/8. Okay, we're going to do a couple more. And then you're going to go to the back side of this handout you printed out or a plain piece of paper that you have. 8 to the 5/3 power. This is an exponential form. I'm putting it in radical form. 8 is the base. It's under. Cube. The denominator is your root, and it's to the 5th power. The cube root of 8 is a perfect cube. It is 2. 2 to the 5th power means 2 times 2 times 2 times 2 times 2. And 2 to the 5th power is 32. Let's do another one. 49 to the negative 1/2 power. I have a negative exponent. Okay, so you can do this a couple of ways. You can just move it down and make this 1 over 49 to the positive 1/2, which makes this 1 over the square root of 49. Remember, the 2 was usually understood for square root, and we don't need the 1, so this becomes 1/7. All right, the last one on this section, 9 to the 1 5/10 power equals 9 to the 3/2 power. Why? Because 1 5/10 means this, 1 5/10 or 1 1/2. And 1 times 2 is 2 plus 1 is 3. This 9 is the base. We take the square root of it and we cube it. The square root of 9 is 3. We cube 3, we get 3 times 3 times 3. That is 27. All right, so far so good. All right, now we're going to convert from radical form to exponential form, and this is going to be, let's see, I'm just going to say write in radical form. So go to your next page if you need to. Oh gosh, I didn't mean to do that. I'm just going to draw a line. Write in exponential form. That means they're going to be in radical, and then it might just ask you to then put it in simplest radical form from there, and I'll show you what I mean as we do it, but we can just leave it to in that other form, so we'll talk about it as we go. Okay, because otherwise it can get kind of confusing if not. All right, so let's look at some of these and see what this means. Another section, so we'll call this number 1. We're going to do the 4th root of x cubed y to the -4th. We're going to see what this means. So now we're taking it out of radical and we're reversing and putting it in the other way. So this means x, the 3 is the numerator, the root is the denominator. So that's x to the 3/4, y to the -4 over 4. Okay? And when we do that, we have x to the 3/4. This is going to stay, right? There's no negatives there, but this is going to move to the bottom. So when we do this, this becomes x to the 3/4 over y to the 4/4. And 4/4 is equivalent to 1. So we get x to the 3/4 over y. That's our answer. That is our answer. All right, we got about 2 minutes left on this section of the video, so I might have time for one more, and then we'll move to, we'll do a second one after that. Second video. All right, number 2. We have the cube root of x squared divided by 8y to the -1st power. Okay, so the best thing to do with this, because it's a quotient, is just take this base. This is my whole base, everything that's inside there. Let's take and make the radical into the exponent. Remember, this would be all to the 1st power. So that's your numerator, and your root is your denominator. So when we do that, now we can share it with everything. So we get 8 to the 2 times 1, or 2/3 power. And no we don't, that's an x, I'm sorry, x to the 2/3 power. Then in the denominator, we get 8 to the 1/3 power, and we get y to the -1/3 power. Okay, x to the 2/3, there's nothing that's going to happen there, but this is negative, it's got to come up. So this is now going to be x to the 2/3, y to the 1/3 in the numerator. And 8 to the 1/3 is the same as the cube root of 8. And what is the cube root of 8? It's 2. So you end up with x to the 2/3, y to the 1/3. We're going to stop the video there, and I will pick up doing some more examples of these in the second part. Okay?